Hello everyone. Now in this particular video, let us discuss about this particular question, that is question number 24. It was asked for 1 mark. Okay. Now this question looks like a joint distribution question, right? So this is based on the joint distribution. Also, we have discussed this thing in detail in our AI course in the case of Bayesian network and Markov chain. I hope you remember that particular things, right? So what is the question given to us? Consider 5 random variables. So this is given to us whose joint distribution satisfied this particular thing. So I have a 5 variable and their joint distribution is given to me like this. Then we have to find out which one of the following statement is false. Okay. So during gate exam, please focus on this type of thing. Because many students make mistake here. They think we have to select which one is true, but that is not the case here. Okay, so sometimes in during gate exam, if you have not done enough practice, then due to exam pressure you can do such silly mistake. Okay, so please focus on this type of questions. Okay, so this is given to us and we need to find out which one is false here. So we can solve this question by joint distribution concept. Also, I can draw a Bayesian network for this particular thing. So we already discussed how to draw Bayesian network for a given distribution, or if a Bayesian network is given to us, then how can we get a joint distribution? Okay. So if I draw a Bayesian network for this particular distribution, it's what? So first here you can see probability of U and probability of V. So this is a marginal probability. So probability of U and probability of V both are marginal probability, right? It means that they are not dependent on anyone. Okay, so I can write this particular thing as like this. So here I have one node U, here I have one node V. So both are independent. Okay, so probability of U and probability of V are marginal probability. Now what about this particular scenario? Probability of W given that U and V. So this is basically a conditional probability of W given U and V. So this is how we can read it. So if I say W here, W is dependent on U and V. So I can do the arrow like this. Yes, this is done. Now what about this particular scenario? Probability of X given W. Right, it means that the condition probability of X given W. So X is dependent on W. So here I have one more node here, X, that is dependent on W. Yes. Now what about this probability Y given W? Same thing, conditional probability of Y given W. So this will be like this Y. So this will be my Bayesian network for this particular joint distribution. Okay, so you should know if a distribution is given to us, how to convert this into a Bayesian network, or if Bayesian network is given to us, how to find out the joint distribution. So this thing is very important in the case of AI course, that is reasoning under uncertainty topic. You should know how to write the joint distribution for Bayesian network. That's it. Okay. Okay, so let's go through one by one. So Y is conditionally independent of V given W. Okay, so from the equation also you can see that Y is dependent on a W only here, and also if you observe this particular network, so Y is conditionally independent of V. So independent of V given W. Yes, that is true because Y is dependent on W only. So this is true. So this is not my correct option. We want false one. Okay. Now what about B? X is conditionally independent of U given W. Similar to option A. Here X is independent of U given W. Yes, because X is dependent on W only. I can write like this. Okay. Okay. So this option is also true. And if you observe here, you can think like that. Suppose X is dependent on W, but W is also dependent on U. So you can say X and U are related. No, that is not like that. Here we are saying given W. So W is already given to us. Okay. So the relation between W and U are not going to consider for this two particular scenario. Okay. So please remember this particular thing. So both option A and B are true. Now what about C option? U and V are conditionally independent given W. So here U and V are conditionally independent given W. See, this is not a correct statement here because W is dependent on U and V. Okay, so W is dependent on U and V. We cannot say that U and V are conditionally independent given W. Okay, so U and V are independent. I am saying U and V are independent. Are independent. Okay, but they are not conditionally independent given W. This is not correct. Okay, so option C is correct here. That is what the false statement is. Because W is influenced by both U and W. If in the sentence we mention that U and V are independent, then that will be correct. But here what we are saying, U and V are conditionally independent given W, then this is not correct. Okay, so U and V are independent variables, that is correct, but they are not conditionally independent given W. So this statement is not correct. Okay, so what this particular statement is saying, the influence of U and V is not there on W, but that is not true, right? So that's why option C is correct here. That is a false statement. What about option number D? X and Y are conditionally independent given W. Now here if you observe, X is dependent on W, Y is also dependent on W, but X and Y are conditionally independent given W. Okay, so this statement is also true. So option D is also true. So only C statement, that is C option, is false. So that will be my correct one. Okay. So I hope you understand the solution for this particular question. Nothing simple one. Whatever we have discussed, if you understand that, then that is good enough. Or you can go through my AI course. In that I have discussed this joint distribution and Bayesian network. So you can go through those particular videos. Okay. So that's it from this particular video. Thank you.